Alright, so let's start talking about angles. Up to this point we've been talking about lines, points, planes, line segments, and so on. Now let's start adding in angles as a second thing. So in order to know an angle, you need to know what a ray is. So rays are 2 points, just like lines. The only difference between a line segment, and ray is the arrows. A ray only has one arrow. Think of a ray as a ray of sunlight. Starts from the sun and goes out in one direction. So we've got ray AB, and notice how I have one arrow. Now the arrow is actually important. The arrow itself is above the B because it goes from A through B. If I wrote it this way, AB, with the arrow going that way, I would actually have to draw a ray that has point B over here and point A by the arrow. So you got to be careful when you're drawing these to make sure, because the arrow actually matters. Lines and line segments, there were either 2 arrows or no arrows, so you couldn't get it wrong. Both sides had an arrow or both sides didn't. Now you have to be specific on which side gets its arrow. So for angles, angles are 2 rays with a common endpoint. So when we talk about a ray, we've got this ray right here. Let's go ahead and call that ray AB. And for it to be an angle, we're going to pick a second ray that starts from this endpoint and goes out in a different direction. And let's call that, get a point over here, point C. So ray AC and AB. So that's how you got to draw an angle. Now, when we name angles, there's 3 very specific ways. You have to have these memorized. You can use the vertex. I could call this angle B. Now I'm able to use that because there are no other angles in this picture. If there's other angles connected to one's point, we can't use just one letter. You could use a number. You're going to see me throughout this whole course use numbers to name angles because really it's just easier. Angle 1, angle 2, angle 3. We could name it using all 3 letters. All 3 letters, you got to go in order. ABC, CBA. So there's 2 possible ones you could do here. Angle ABC, start from one edge, go to the vertex, go to the other edge, or angle CBA. Now, something to pay attention to. Most important part. The vertex is in the middle. The vertex is where the 2 rays meet. Okay? As long as the vertex is in the middle, you've named it correctly. On this one, take a minute, try looking at these, try answering all 6 of these, and then unpause it when you're done and we'll check our answers. Okay, so let's check our answers. What is the vertex of angle 5? Angle 5 is right here, meaning it's this angle, and the point that's right next to the number 5 is M. Vertex of angle 8. Angle 8 goes from M to O to P, or from P to O to M, but either way, O is in the middle. Name the sides of angle 1. So angle 1, let's go ahead and actually trace this. Angle 1 is right there. So when we go to name the sides, we have 2 rays. Remember, that's the important part. We have ray PM and we have ray PO. Naming the sides, you actually have to have rays, not just the 2 letters. Name the sides of angle 2. Let's get rid of this. Angle 2, same thing, we'll trace it here. We have PM again. And in this case now we have PR. Angle 3, we want to name it a different way. Well, instead of angle 3, we could say angle P. The only problem with calling it angle P is there's 4 angles there. There's this one over here, angle 1, angle 2, and angle 3. All of those have P as their vertex, so we have to use 3 letters. I'm going to start with Q, then P, then R. Remember, as long as the vertex is in the middle, you're fine. Oops. let's get that back on there. And now name angle 6 in another way. We're going to do the same thing. The only difference is there's no other angles here that have other important significance, so we're able to just call this one angle N. Alright, so let's classify. There's 4 key terms that we have to talk about for angles. We have right angles, we have straight angles, we have acute angles, and we have obtuse angles. Take a minute, just read over these, make sure you can answer them on your own, and then we'll check. So a right angle is exactly 90 degrees. A straight angle is exactly 180 degrees. An acute angle is less than 90 degrees. And an obtuse angle measures more than 90 degrees. Those are ones that are going to be used throughout the whole year. They need to be committed to memory if they aren't already. Alright, example 2. We're going to name these as right, obtuse, acute, or straight. For sake of handwriting, I'm going to use just the first letter of each one. Angle PMN. Remember, start at P, go to M, then go to N. PMN. That's a right angle because there's a mark in there that says it's a right angle. NMO. NMO. Well, if PMN's 90 degrees, NMO is less than 90 degrees, so that's acute. LMN goes across a straight line, making it a straight angle. QMN is bigger than 90 degrees, making it obtuse. PML, so if this over here is 90 degrees, that means this one over here is also 90 degrees. So that's a right angle. PMO, just one of these small sections. It's acute because it's less than 90 degrees. And then angle OML starts over here and goes all the way to L. That angle is bigger than 90 degrees, so it's obtuse. Alright, let's start throwing in some numbers. Angle EFL, 62 degrees. Angle LFG is 86 degrees. I need to find angle EFG. Well, EFG is the entire thing. So, 62 plus 86, add them up, you got 148 degrees. Alright, now let's throw in some algebra. We know angle VUT is 133 degrees. So the entire angle is 133. And I'm going to usually put that up there like that to label it, and then everything that is inside I'll label nice and small on the inside. Sorry, getting a thinner pen. Alright, angle GUT is 2x plus 11. That looks like a 4. 2x plus 11. And angle VUG is 10x minus 10. Okay, so we know that in segments, the two small segments add up to the whole. Well, that applies for angles too. The two small angles add up to the whole angle. So we got 2x plus 11 plus 10x minus 10 is equal to 133. I'm going to combine like terms. We got 12x. 11 minus 10 is 1. Oop, getting ahead of myself. I'm going to subtract 1 from both sides. Got 12x equals 132. Divide by 12. X is 11. Now, remember back a couple videos ago, just because x is 11 doesn't mean we're done. The question actually asks find angle VUG. So we're going to take x and we're going to plug it in. So in place of x, I'm going to plug in 11. 10 times 11, 110. And I get 100 degrees. Alright, angle bisectors. We talked about segment bisectors. They split a segment in half. Angle bisectors split an angle in half. So let me draw an angle here. Let's name it ABC again. Alright, so an angle bisector, what it's going to do is it's going to take whatever degrees this is and split it exactly in half. So let's say, for instance, right now, that this entire angle here is 140 degrees. I'm going to take an angle bisector that starts at the vertex and goes right in the middle, and right now I'm estimating. Since the entire angle is 140 degrees, that means each one of these splits to 70. Alright, so if angle PQS is congruent to SQT, since they're congruent, I'm going to put a mark similar to how I did for segments to mark that they're congruent. That means that this line here, QS, is an angle bisector. We know TQR is 127 degrees. I need to find the measure of SQT. So I'm going to name that X since there's no other variables. Since that's X, since we know they're congruent, that's X as well. Angle PQR makes up a straight line, which means it's a straight angle. All straight angles add up to 180 degrees. So X plus the 127 equals 180 degrees. I'm going to start solving. I'm going to take my two x's, combine them, and I'm going to subtract the 127 in one step just to save some work. And I get 53. Then I'm going to divide by 2, and I get x is 26.5, which means the measure of angle SQT is equal to 26.5. Let's try that again.